Alright, Will Justice gonna show how to make hydrogen using my solar panel from a toy. This is just a little toy. This can be scaled up and done heavily on a bigger production. Right, first we have what's that? I don't know what's going on. First we have simple. We have a cup. Well, not a cup. It's about a gallon of salt water. This is regular table salt. The only thing you see in there floating right now, that is just regular dishwashing liquid. It's only so you can see the bubbles visually. Alright? This doesn't change anything. It's only table salt and water dissolved. Second, we have solar panel. Already linked in series, 1.5 volts per panel, which links up into series to be 4.5 volts. Linked in series. Right. And then we have the most important element here, the sun, which makes these actually work. Excuse me. So, what I have is, oh man, I forgot my wires. Right, while I'm getting my wires, they explain this, what hydrogen is good for. Hydrogen is it's a combustive. Hydrogen is a combustive gas. You can use it instead of petroleum gas. So instead of petroleum gas, you can use this in order to run your combustion engine. All I need is 2 wires. All I have is copper wire that I took from a dead charger. It's a charger that wasn't working anymore, like for your phone, that plugs into the wall. And what I did was strip down the wires out of the plastic into and coiled, excuse me. I have a bare wire. Alright, excuse me. Yeah, let the light catch up here. Alright, so we have just regular copper wiring that I have coiled by hand that came off of a charger, a phone charger. Then that's for my negative, because we want as much surface exposed in order to get the hydrogen off of. The hydrogen is gonna collect around that wire. Then I have, for my positive, I've partially stripped it from the wire. Now this is going to oxidize, which means you're going to have rust on the surface of this wire, because the oxygen is actually going to break it down. Now, what I'm going to do, quite simply, is this. I have one more thing. In order to capture, where's my jar? I had to go get my jar. I'm getting my jar what happens is I had some young ones that I previously taught this to, and they're being real ignorant right now. They don't want to be on film. So I'm gonna do is I'm just gonna do this myself, and it's already been taught to them. So I mean, they learned the lesson. They don't have to be on film. Where's that bottle at? I'll leave it. Oh, I put it in my pocket. Yeah, I'm slow. Hey, I put it in my pocket. Oh, I left it out here. So I have, it's in my pocket, a jar. This is a regular jelly jar I had. It's a preserve jar. I always reuse things that you don't need to let things go to waste. Waste not, want not. Do that a lot. So simply this is just a regular jar. Just a regular jar. There's nothing in it. Oops. Nothing in it. What I'm going to do is, because of this placement, of course this is going to let a little water spill, but I'm trying to let all of the air out of this. Simple. Put it in, turn it upwards, make sure all the air is out of it. Let's turn it upside down. Okay. Now, what I'm going to do is, I'm going to link first. I'm going to link up the negative wire. This is in series, mind you. So that we're getting 4.5 volts, which is 1.5 times 3. We have 3 panels, 1.5 apiece. Simply going to take, oh, that's the positive. I'd rather it be the other way around, but I'm going to take the negative. Simple. Bare wire. Negative. Loop it around. Make sure it has it's touching. Negative. Oops. Goodness. Negative wire connected. We have positive. Like I said, I have left surface area because what I'm going to do, I just need the charge to go through the water. The only thing the salt does, the salt helps to keep or make the charge a little bit more powerful. So what you do is you have to be careful. You'll get a slight shock if you're not being careful. I recommend keep it face down when you're placing it into the water, because you will receive a shock. This is direct current. That means it's going to be a lot more powerful than the AC, which is alternating current. So what you have to do is take the negative wire, place it underneath the jar. I'm going to do this, and let me set this up. All right. So what I'm going to do is take the naked wire. I'm going to just coil it a little bit. Doesn't have to be drastic coils. And put it underneath water. Mind you, it's gonna have a little bit of spillage. It's not gonna hurt much. Keep that water inside. This is one to you can't say it's difficult. It's just a little bit more challenging parts. You could also use like a silver spoon or a steel spoon or what have you in order to create more surface area. In order to keep it simpler, I just use the naked wire. Just put it in there. Ah man, it's not going too good. It's alright. Worked better last time. So the wire goes all the way in there. Right. All while we are ensuring that we are not, letting any air into it. This is down. Now, what I've done is, there's only one extra element in there, which is the bubbles. So you can see some bubbles. I put some some regular dishwashing liquid in there. Alright, now this is hot when you have the sun on. When I place in the positive, we complete the current. Make sure the two wires are not touching. You have the sun on. What's gonna happen, I can already see bubbles forming. Alright? As soon as the current is introduced, this is going to take a while, but the bubbles are being produced. The bubbles are actually hydrogen, which can be used in order to fuel any combustion engine and many other different applications. So I'm going to come back maybe in about an hour or two and see how far along we're progressing. So this is making hydrogen using the solar panel. I'm actually in the sun, so that we may apply it. See the bubbles popping up little by little. We may apply this practically instead of fossil fuels.